Okay. Hello and welcome to the Sydney.net user group. I'm Jason Taylor, for those of you who don't know me, and usually we like to kick it off by asking who is here for the first time. Oh wow, like pretty much half the room, cool. And what brought you here tonight? Was it the pizza or the location or the topic? Topic? Cool, okay, that's great. And what are you guys working with? Are you working with .NET Core primarily? Anyone still on .NET Framework? Yeah. Cool, yeah, a few, that's okay. On like latest version or? Yep. Cool, and anyone programming in .NET Core 2.1 yet? Released to production? First guy?
Just started this week.
Wow, congratulations, that's awesome. So you're the only guy. You've shipped to production as well, 2.1.
Yeah, last Friday.
Oh, see, I've been doing this talk, and now I'm behind. Everywhere else I went, nobody had shipped to production, and so I'd say, oh, so you guys are all writing legacy code too. But no, there's two guns here, and they're in production with 2.1. Fantastic. Okay. So for the rest of us, hands up, show of hands, 2.0 in production. Yeah, 1. 1.1. Yep, 2 and 1.0. Just the one, yeah. So definitely worth upgrading to 2.1. I think the big thing with .NET Core 2.1, including ASP.NET Core and EF Core, is that they've kind of bridged all the gaps now. So a lot of the features that were missing in some of those earlier versions have been implemented. There's still a little way to go, but definitely the primary gaps have been filled. So talking about news, does anyone have any exciting news they'd like to share? Technology related or otherwise?
Pizza was great.
What was that? Pizza was great? Fantastic. Cool. Good reason to come to the group and not just chill at home watching the live stream. What's that? Oh, did you? Yeah, no. Yeah, no, we always have pizza. We always have pizza, so that's good. Well, I think the big news for me over the past month was Angular 6 was released, so that's very exciting. A lot of great features there, and of course .NET Core 2.1 and all of those other ones. And then there was
another release of Blazor.
Another release of Blazor. So what is it? 0.4?
I have no idea.
Yeah. So it's definitely bleeding edge. So you can use it, but you'll have tears and a lot of blood. So, yeah. Anyone using Blazor in production? No, that'd be really brave. Yes. And then of course Microsoft acquired GitHub, so that's pretty exciting. Anyone think that's a good thing? Anyone think it's a bad thing?
We'll see.
Yeah, that's pretty much it. Yeah, no one raised their hand, so it's just we'll see. What will they do with it? Might be good, might be bad. We'll see. All right, well, let's kick it off then. So tonight we're talking about enterprise apps with ASP.NET Core 2.1. As I said, I'm Jason. I'm a SSW solution architect, and I'm actually from Brisbane. I've been developing since 1992, but not professionally. I've been developing professionally since 2001. In 1992, someone was kind enough to gift me a Commodore 64. And it was pretty great. It had a 1 megahertz CPU, 20K of memory. It used to fly. I have a Surface Book now, and it has an i7, and it has 16 gig of RAM and an SSD, and it's a bit slow sometimes, I gotta say. It's holding me back. I developed on the Commodore 64 for about a year in BASIC, but then I found out that I could get video games for it. So I played video games until about 2001, when I got my first professional job programming. Over the last 2 years, I've been focused primarily on .NET Core and Angular applications. So we've shipped many applications to production, and tonight I want to show you some things that I've learned around structuring the architecture and design of those applications. And the focus is going to be primarily on clean architecture. So just a show of hands, who's heard of clean architecture? Okay, cool, 5, 6 people. And but who's heard of onion architecture? Okay. Cool, a few people. So onion architecture, clean architecture, hexagonal architecture, ports and adapters, those are all examples of domain-driven design type architectures. And clean architecture is kind of recognizing that they all have 5 things in common. And so we're going to talk about those 5 things that they have in common, and then we're going to have a look at an actual project and how that's structured, and some exciting tools and techniques that you can use to make your life easier. So we'll start by talking about the architecture and design, and then we'll move in across each of the layers. So the domain layer, the application layer, persistence layer, which is where we'll put all of our data concerns, infrastructure layer for our external concerns, and our presentation layer. So let's kick it off. So clean architecture has 5 things that are important, as does the other similar architectures. So it's independent of frameworks. So this architecture is not dependent on some web framework or some tool in the way that you design your system. It's highly testable, and we're going to talk about this in a little bit of detail, but you can test each layer of the architecture, and it's clear what type of tests you need to write for each layer. It's independent of the UI, which is really important in today's world, because I guess the pace of change in web technologies is so fast, and keeping up can be hard. And implementing clean architecture, we can actually make it quite simple in which to move with those changes or to replace it with something else entirely. It's independent of the database, so we're not dependent on some implementation that uses SQL Server or Oracle or MySQL. We build our application in such a way so that we can switch that out later if we need to. It's also independent of any other external agency. So if you have some external web service that you call in, like SharePoint or just some other web API, it's not dependent on that. It's not dependent on the implementation. And the way that they do that is they push all things to the outside of what's important. So let's talk about what's important in clean architecture. So at the center, as I said, it's a domain-driven design type architecture. So the domain is there. And that's where we have all of our domain types and our domain logic. And you might wonder, like I used to, what domain logic was about. It's the enterprise-wide logic. It's the logic that's not specific to the application you're building that could actually be transferred into another application that's for a completely different area. So just the enterprise logic. So where do we put our actual business logic that's specific to this application? We put it in the application layer. So this is the logic that's specific to this application, but not specific to the enterprise. You wouldn't move it into some other application. And then we surround that with our presentation. So that can be whatever it is that we're building. A lot of the time for us, it's multiple things. So we might have a web application, which is an Angular SPA. We might have a mobile app. We might have a console application for some background or scheduled tasks. It can be any of those things, Razor Pages or Blazor, as you said. So then we have our persistence layer. So persistence layer is where we put all of our data persistence concerns. So in this case, it'd be entity framework. In this particular demonstration I'm showing tonight, it'll be entity framework 2.1. And then finally, we have our infrastructure layer. And that's, persistence is really part of infrastructure as well. So you could actually just extend that circle around and say, yeah, persistence sits within there. It's basically anything else external that we require. So a good example of something that would go in infrastructure is a notification service. So if you need to send notifications via SMTP or SendGrid, you can put it into there. If you're accessing an external web API, the actual code that does the accessing, the implementation, that's in the infrastructure layer as well. We have to talk also about the dependencies, because without the dependencies, this doesn't make much sense. So the first one is the presentation layer is dependent on the application layer. And you can see the direction it flows in. That's really important. So we're implementing the dependency inversion principle, which states that the implementation, what's the best way to put it? So in this case, in the application layer, I put the abstractions, so the interfaces, and in the presentation layer, I put the implementations. So in the presentation layer, it has a direct reference on the application layer, and the application layer contains all of our business logic. So in the example tonight, I've implemented Northwind, and Northwind's all about products and customers and orders. And so the things that you'll see in the application layer are things like create customer, create order, get a list of products. So that's what the business logic for this application is. And then next we have a dependency from application into domain. So that layer is so that it can read all of the entities, the enumerations, the value objects, and the domain logic, whatever it is that we have in that layer. And then next we have the persistence layer is dependent on the application. And this is an important part where the dependency inversion principle plays in. So if we have the application layer dependent on persistence, then that means we're actually dependent on the implementation that we're using. So if application layer is dependent on persistence, then the whole application is dependent on entity framework core in this case. Because we've got it pointing the other way, then that means that we'll need to implement some abstractions. So if we wanted to keep it in that direction, in our application layer we'll put a I repository perhaps and an I unit of work, and in our persistence layer we'll create the implementations for those interfaces. So the application layer doesn't know anything about persistence, and in that way it's completely independent. And then next we have the infrastructure layer, which is exactly the same. If the application layer needs something from the outside world, it creates an interface within the application layer, and it's up to the infrastructure layer to actually implement that interface. And because the application layer doesn't know anything about the implementation, we can switch that out at any time. So if we're doing notifications via email using one method, we can switch it out to another method without actually impacting what is in the application layer. And so when we talk about this design being testable, we're talking about not just those external layers, but more importantly, the application and the domain layer. And that's what we refer to as the core of our application. So the core of our application contains all of that logic, but doesn't have any dependencies on anything external of the core. And that means that it's really easy to test. So you can unit test the entire core without actually having to worry about accessing external resources. It's not connecting to the database, it's not connecting to some notification service or some external web API. So 100% of the tests in there are just unit tests. So that's really easy and it's really clear. When you look at the presentation layer, the tests that we're going to write there, pretty much just UI tests. So we could use Coded UI or Selenium, whatever our favorite tools are, that's going to be the majority of it. In the persistence layer and the infrastructure layer, we're writing functional tests because integration tests. So they're working with some kind of external services. It's primarily just about implementations. So we write integration tests for those. Now within those layers, there might be some internal logic that they're using, and so there'll be some unit tests for that, but the bulk of what we do there would be integration tests. So it's quite simple. Before we move on, I'd just like to ask, does anyone have any questions? Yes? Yeah, no problem.
First, if our application is talking with some external, in cloud, for example, Amazon S3 to store or retrieve images or something.
Yes.
Is that the job of persistence or infrastructure?
So let me repeat the question just to confirm that I've got it right. So if our application is communicating with some external service such as Amazon to receive product images, is that the job of the persistence layer or the infrastructure layer? Yeah, so it's definitely the job of the infrastructure layer to communicate with that external service. But the important thing to realize here is that it's the job of the application layer to actually write the logic that interacts with that service. So the implementation will sit in infrastructure, and that'll be communicating with Amazon, and it'll basically be getting images, but there'll be an interface there in application layer, and it'll probably be called Amazon service, right? And so the business logic that you write that integrates with that will just know about the interface. And so then if there was some element of persistence, it'd be the application layer that actually ends up using the repository to persist that.
So if we store the images as well in the Amazon, is that again infrastructure?
Yes, that's right. Yeah. Unless you had kind of direct access to the database and you were thinking of doing it that way. But it is kind of a gray area because, as I said earlier, that whole bottom circle, it's infrastructure. So the fact that I've separated persistence is just because we're kind of working with Entity Framework Core and we're going to treat it a little bit differently tonight. But it's all infrastructure. So yeah.
My second question is, for example, you said the Amazon that the applications knows about.
Yes.
So IOC container, will go inside application or somewhere like UI
Depends on your application. For something simple, like if you're just building a spa, then it can easily go into the web UI, or you can put it into a separate layer.
And the third one, also they said that domain, according to domain-driven design,
Yes.
our entity classes shouldn't be DOM, they should have some logic, shouldn't be properties.
Yes.
So we will have logic in domain and also logic in application.
Yes, correct. So I'll just repeat the question. So in domain-driven design, it states that our domain classes, our entities, should have logic. They shouldn't be kind of anemic. So yes, in this design, you can have domain logic as well. Definitely recommend it. And that's when I talk about what logic do you put in there. Well, it's the enterprise-wide logic. It's the logic that can be transferred from one application to the next, whereas the application logic is the logic that's specific to this application that we're building. So you could think of the application logic as being the business cases. So this is what we need to do when we're creating a customer. This is what we need to do when we're creating an order. You know, because when we create an order, we've got to persist the order, but we've also got to send out a bunch of notifications and communicate with external services. And so in the application layer, that's where we orchestrate all of that.
Do you put the validation in the domain?
No, I'd put well, look, with architecture and design, it always depends. But generally, with the applications that I'm building, I'm putting the application, the validation logic into the application layer because it's the data that's coming from the presentation layer in the outside world that I'm validating most of the time. But for complex designs, there's definitely an element of validation that could go into the domain layer as well. We're going to talk about that in a little bit of detail too.
Security and access control?
Security and access control, that's a good question. So it depends on what you're using, but typically it's going to be in the infrastructure layer. So anything external, because you're going to want to switch that out with something else at some point perhaps. So a little bit of abstraction there can help. But it does depend. It always depends with architecture and design.
So what's ended up in the domain and the center?
In the domain, let's wait till we come to that topic and I'll cover it in detail for you. All right. So one of the things that's quite common for .NET developers, especially today, is the question, should we be implementing the unit of work and repository patterns? So show of hands, who thinks just generally that we should be implementing these patterns? Yep, I like them too. Yep, so one person. And so I'm going to take it that, look, show of hands, who thinks we shouldn't implement them? Who thinks we should use Entity Framework directly? Okay, so we've got one person so we've got one person either way, and the other people are undecided. So let's talk about, should we implement these patterns? I'd say that it's not always the best choice, just simply because of the way Entity Framework Core has been designed. We've got 4 things here. So the DB context insulates your code from database changes. So you might want to implement those patterns, for example, so that you're not dependent on some database like SQL Server or MySQL. But in actual fact, Entity Framework is one big abstraction. So if you want to change out from SQL Server to Oracle later on, you can do that. It doesn't actually change the way that you work with Entity Framework. And the way that you do that is just by changing the provider. So maybe you're using Microsoft Entity Framework Core SQL Server, well, you can change that for Microsoft Entity Framework Core Postgres. So the DB context insulates your code from those database changes. The next one is the DB context actually is a unit of work, and the DB set actually is a repository. So that provides the benefits that you get from both of those patterns. So you wouldn't implement it to have those benefits. You'd implement it for some other reason. And some other reason might be for a complex design, you might have what are known as aggregate routes. So, and in an aggregate route, you might want to control access to a set of objects through a repository. So a good example of that I like to give is you have an order, and an order has order details. And you don't want a developer to be able to update order details individually. You only want them to be able to update it as a set. So when when they're using the repository, they pass in the order along with all the order details, and that means that you can provide some validations and checks and balances when they do that, because you're doing it as a set at the aggregate root. So that would be a good reason to implement a repository. Another good reason is you might want to implement the cache repository pattern. So that's, if you've got a repository and then you decide you want to implement caching at that level, then it's very trivial. You take your base repository, derive from that, and just put your caching around that. So there's quite a few different reasons that you might want to use repositories. In the past, we did it so that we could unit test effectively, but many of you probably know nowadays we can just use the EF Core in-memory provider or the SQLite in-memory provider, so we can actually write effective unit tests even if we're dependent on the DB context. So I think a lot of the time we don't need it, and so that's why I've kind of made a change to this design for my purposes, and that is to actually reinvert the dependency on persistence to the application layer. So we switch that around, so the application layer takes a dependency on persistence. And of course that has some pros and cons. The pros are that we get to use Entity Framework directly, and we get all of the richness that comes with Entity Framework, and it's not hidden behind some abstraction, which can be quite painful. The cons are that we're now dependent on Entity Framework Core, and Entity Framework Core might be only around for 5 years, whereas our application core, the application and the domain, is probably going to be around for 20 years. The business has said this is a throwaway application, but it's still going to be there. They don't really mean that. They just tell us that so we move faster. Don't believe it. So let's have a look. Key points. Domain contains enterprise-wide types and logic. Application contains application-specific models and logic, so your view models and DTOs. The infrastructure, including persistence, contains all of our external concerns. The presentation contains our front-end apps, and that can be absolutely anything, but the important thing there is they only communicate with the application layer. So I don't think I made this point. The presentation layer doesn't communicate with the infrastructure either, only the application layer. And infrastructure and presentation components can be replaced with minimal effort. So of course it depends on the size of your effort, of your application, but you're in a much better position to replace those components with this architecture and design. All right, so let's have a talk about the domain layer. So as we know, the domain sits at the center, and it contains our entities, our value objects, enumerations, logic, and exceptions. And I want to just dive right in and start showing you some code now. So I've built this application. It serves two purposes. This is called Northwind Traders, and I'll include a link to this at the end of the presentation. But I built this so that I had an application that I could play with and try new things on. Northwind is a fairly well-established model, so it has some complexity in it, and it has a lot of data in it. So if you're wanting to use this, you can come and grab it. It's built on .NET Core 2.1 with EF Core 2.1, and it includes full data seeding, so it's quite extensive. But what I've done recently is to upgrade it to implement the architecture and design that I've demonstrated here tonight. So we're going to use this for all of our demonstrations. So let's have a look. Just hide this. So you can see here that it's fully documented. I've got a README documentation which describes the solution as a whole. But then in each of the projects which represent the layers, I've also got a README. So you can jump in there and learn more about each layer and what should be contained in that layer. So that's true of all of these layers. But we're going to talk about the domain now. So you can see here that I've kept it simple. I've got 4 folders: entities, enumerations, exceptions, and value objects. And let's start by talking about some key points. So one of the things that I think is good to do is to keep data annotations out of your entities, because that's somewhat of a persistence concern anyway. The data annotations tells us that, or tells Entity Framework as an ORM how it needs to map that to the actual database. So I like to keep those out of the actual entity so that I can keep them as clean as possible. And when we talk about the persistence layer, we'll talk about the Fluent API configuration, how we use that to avoid using data annotations at this layer. So the next thing that I like to talk about is always defining your foreign keys. So we have an order, I'll just zoom in here. Is this big enough for everyone to see? Mm-hmm. Okay, great. So we have this order entity here, and if I jump into there we go. You can see it has a foreign key to customer. And that's kind of important, because if we don't create that foreign key, and this is talking about persistence a little bit here, if we don't create it, Entity Framework will go and create it anyway, but we don't get to use it. And it's important to be able to have access to that, because you can't do things as efficiently without it. So if I have a look at just a little bit of application logic, I have this command which is responsible for creating a product. And you can see here it's quite simple. First, it gets the category from the database based on a category ID. Then it gets the supplier from the database based on a supplier ID. And then it creates a new product and persists that. So that's all it does. But if we don't have the foreign keys, that's the way we have to do it. We have to actually make 3 database calls in this case to get the entities that are associated with this. But if we actually have defined our foreign keys, we can delete these and actually just set the foreign keys. So it makes it a lot easier, because we probably have those foreign keys. They came back from from the presentation layer, and we don't have to make those requests at all. So kind of simple, but good to know if you don't already know that. Next recommendation. Yes?
If you put it this way, even without foreign keys, right, it will save this entity. And
Fine, yes.
And it will save it anyway. So why do you need foreign keys for doing this
Yes,
work?
that's a great question. So the question is, if we do it this way without foreign keys, it will still save the entity. So why would we do it that way? We don't need the foreign keys for that. Well, the difference here is that with the foreign keys, we didn't need to make a database request to get the category and to get the supplier ID. We were just able to actually set the foreign key. So without the foreign key, you can't establish that relationship unless you have the entity.
So it saves you time, and I guess it's more efficient.
Yeah, so less database requests.
I'm not getting why do you need to make this database request at all. So when you save an entity, you put
Yes.
ID equal, right?
Mm-hmm.
Even if there is no foreign key defined, right? You just define plain entities. You didn't define any foreign keys, just primary keys, plain entities. Your entity framework has no idea about relations between them.
Mm-hmm.
Actually, it can guess from these names of properties, but
Yeah, so the
let's leave
conventions.
aside. So, and you save it like that, it will save. And when you need to read this entity, right, you write a new query, unless you're using techniques like lazy loading and things like that, right? You switched it off for performance or whatever.
Yeah.
Right? It won't create proxies over your objects
Yeah.
when it loads up. So you can load whatever, you can say category equal and join it, a table with categories by this ID
Mm-hmm.
when you query the entity, and it gives you full control of what you're loading up, right?
Yeah. Well, let's keep it on just the saving for the moment. So without the foreign keys, without the category ID and the supplier ID being defined on the model, how do I save those values without actually getting the category and the supplier from the database?
You should have these fields defined.
Well, that's exactly what
But
I'm
you
saying.
don't define them as a foreign key. So foreign key as a relationship, you define an entity framework.
So,
and
okay.
The field itself is
Yeah.
you can do that.
So you're talking about using, so you're saying don't define them, you don't need to define them as a foreign key. And so you're talking about actually saying using Fluent API configuration or data annotations to actually mark them as a foreign key?
Not marking, you just having a category ID property,
Yep.
supplier
And by
ID,
convention,
and you just using them as is.
Yes.
Just the field.
You just have to
yeah,
stick to this convention. That
that's
happens,
right,
like,
yeah.
ID in the end and the name of the
Yeah.
entity.
So that's when I say having the foreign key. I'm not saying that you actually need to mark it as a foreign key or that you have to use Fluent API configuration. I'm just saying have it. So definitely use the convention over configuration whenever you can. And that's one of the points that I'll make in the persistence layer. So it sounds like we're on the same page. We're just, about how we define those foreign keys. So I'll just undo that. Same result. Okay, so the next one that I wanted to talk about is collections. So a lot of times when people are working with these collections in their entities, they won't initialize them. And I think that can be a bit of a mistake, because if you don't initialize the collection, and this is how you would initialize it, then you have to write logic to check if it has been initialized. And this logic just seems to just creep all over the place, and it's annoying. And like then you might forget to write the logic, and then your application crashes, and so then you just go and initialize it. Save yourself all of that pain, and just whenever you have a collection, really in your entity or your DTOs or your view models, just initialize it. And if you want to take one step further, you can actually remove the setter, and Entity Framework will work just fine, Entity Framework core, or you can make it a private setter if you wanted to use it in a slightly different way. And what that means is that you know it's initialized, so you don't have to worry about it. But then other developers who come and work on your system, if they try to initialize it, they're not going to be able to. It'll show them a warning, and that's going to kind of help them to use the conventions that you're using, use that same style. So it'll teach them. I think sometimes people talk about it as the pit of success. Make it easy for your developers to do the right things and hard for your developers to do the wrong thing. Well, this is an example of that. Now the next one I want to talk about is using value objects over primitive types. So who here knows what a value object is? Yep, so a couple of us. So a value object's quite simple. I've got a good example here, so I think I'll just run through the example. So let me jump to this user entity. I have this user entity, and you can see it's got a property, and it's of type string, and it's an AD account. But a string doesn't really represent an AD account that well. It's a primitive type. It's designed to represent strings, but perhaps not AD accounts. So an AD account consists of a domain, and it consists of a username, and it can be displayed in various ways, and all of those things are what makes up an AD account. So if we store it as a string, then in our domain layer and our application layer, we'll probably have to do some manipulation on it. You know, maybe sometimes we'll want domain / username, maybe sometimes we'll just want username, and this is another example of logic that starts to creep throughout the system, especially with new developers. You know, maybe you've got a helper class somewhere, but they don't know to use it because it's not obvious. Well, if you use a value object, then you can have a type that specifically represents what it is that you're trying to store. So I've got a value object called AD account, and you can see it has a private constructor, which is just needed for working with EF Core, but it has this public constructor, which we can use. So we can pass in a value, which would be a domain / username, and it will actually split it into the domain and the name. It'll throw a domain exception if there's some kind of problem with that. And that's a you know, it's a trivial exception, but it's a really great exception to have, because the alternate would be index out of range exception, which is hard to debug. This one's really clear. And so you can see here, there's our domain properties. Value objects are immutable, so we've got private setters on those, which we could probably take out. And then we have some implicit operators and explicit operators. And I've got some unit tests for that, so it's better to look at the unit tests rather than try to talk about it from another perspective. So you can see here this first test, it just says that if I new up an AD account, it should have the correct domain. So I new up an AD account by passing in this string, and we assert that it's got the right domain. So that's simple. Then, but the benefit there is I can get the domain. Like before, I had an AD account that was a string, and I had to do string manipulation to get the domain out. Now I can just get it, and that's logic that's used anywhere. And I should have the correct name, so username. So that's simple. But I've also actually in the value object overloaded toString, so I can return the formatted version really simply. So I test that works well. And this is where I see a lot of cool value. So we've got the implicit conversion operator. So I can take a AD account, and I can just assign it to a string, and that'll implicitly convert it to the string, and it'll just use the toString method, which I've overloaded. And then we've got the explicit conversion, so I can actually just force it to cast. So I can take a string and force it across. So I can work with this in a number of different ways, which makes it quite easy. And it's, you know, new developers who try to work with this object, they're not going to kind of question, how do I work with this object? Where do I get the logic from? Because it exposes the methods and operations that it's capable of doing. So, and that's the other point is, yeah, definitely use custom exceptions rather than the built-in exceptions, because when it comes time to debug, a custom exception that's specific to kind of the domain or the application logic is a lot easier to debug. It makes a lot more sense than a kind of built-in exception. So.
Do you override some base methods like equal or to hash?
Yeah, sorry.
Convertible.
That's a great question. Shouldn't I write some base methods like equal or hash and that sort of thing so we can do comparisons? And yeah, that's really important, and I should have covered that. So I've actually borrowed this value object base class, and you can actually find it here. So I'll give you a reference to the source code, but it's in Microsoft's .NET Architecture Guidance microservices book, and it implements all of that, so we don't have to worry about it. Pretty much the only thing that we have to do is just inherit from this value object and then implement this get atomic values method. So we just yield return any of the properties that make up our value object, and it's able to then do all of those sorts of comparisons. So yes, good question. We're going to talk about how Entity Framework Core works with that value object a little bit later on as well, how it stores it in the database and that sort of thing. All right, so the key points, use data annotation sparingly, if at all. It's always going to depend, but I definitely prefer to keep them out of my domain and use the Fluent API configuration, which we'll look at soon. I think always define your foreign keys. If you don't, you just don't get the benefit of having them there. As I said, Entity Framework is going to go ahead and create them as shadow properties anyway, so you might as well have them exposed so that you can use them. Use value objects where appropriate, and consider if you're using a primitive type, if that is the best use of that primitive type, because you know a postcode is not really an integer. It has some very specific properties about it. Initialize all collections, maybe consider removing the setter or at least setting it to private, and create custom domain exceptions where appropriate. All right. So we'll jump into the next section, which is the application layer. So this is the next part of what we consider the core of our architecture and design. And it contains the interfaces. So interfaces for persistence, if we're setting up the abstractions, and interfaces for infrastructure. It contains models, so view models or DTOs. It contains our application logic, our validators, our events, if we've got any kind of application events, and any exceptions, so custom exceptions. So we're going to have a look at the application layer next. Okay. Okay, so you can see here that I've pretty much split it up by feature in the application layer. So I've got my categories, customers, employees, managers, notifications, that sort of thing. And I've also got a little bit of infrastructure, which we'll talk about later, which is just kind of helper classes, but they do something pretty special. I've got my interfaces here. So in this case, I've got an example repository, and I've got an example notification service. So this is just to illustrate, we're not using the repository, but it's to illustrate that this is exactly where the repository interface would sit, where the unit of work interface would sit, or if we were just creating some kind of specialized data service, that's where the interface would sit. And so we can write our application logic against those interfaces rather than any kind of implementation. Okay, let's see. First thing that I want to talk about is the command query responsibility segregation pattern. So the command query responsibility segregation pattern basically says that we split our reads up from our writes. And when you start to dig into the pattern, you start to hear a lot of things about having separate data sources for reads and separate data sources for writes, and also you hear about event sourcing. But there's a much simpler way that you can use CQRS, and that's just to have really well-defined separation of concerns. So if you think about it from the CRUD perspective and say a customer, we've got a few things that we want to do. We want to get a list of customers. We want to get a specific customer and all of their details. We want to create a customer, update a customer, and delete a customer. So using the CQRS, I can split those into 5 different objects. And that's exactly what I've done here. So I've got my customers folder, and inside I've got my commands, my queries, my models, and my validators. And so if I expand out my commands, you can see, I'll just zoom out a little bit, make this a bit bigger. You can see that I've got 3 commands. I've got a create customer command, a delete customer command, and an update customer command. And then in my queries, I've got get customer detail query and get customer list query. So these are really, this is a really simple approach to splitting apart your logic. You could also create, say, a customer service, which contains all of those sorts of things. But the important thing is that the logic is in the application layer. Now, I've taken a bit of a different approach to CQRS lately, but I want to show you, wow, that's unfortunate. Well, we'll do a quick reboot. And yeah.
Is it the same on your screen? Or?
I don't, I think it's, yeah, no, it's my screen. The display is correct. No, that's okay, I'm going to reboot. No, well, it has happened before on this machine, but I was hoping it wouldn't happen again. It didn't happen in Brisbane, Canberra, or Melbourne. And I was kind of thinking, maybe it's gone away. But this is a new Surface Book. I got it replaced under warranty, so. Yeah. But it boots really fast, so we'll be back in action. Good time for questions. No questions?
Basically, like,
do you usually keep like those queries and commands in the same folder? Because like here you have all the examples like for customers.
Yeah.
And you end up doing it for each domain entity. You end up having a huge amount of these commands.
Yeah.
Do you use like separate folders for each entity?
That's a really good question. So, do we have separate folders for each entity in the application layer? And then I guess separate folders for the commands and queries. I don't think that I would end up creating them for each entity. I really want to focus on, and I probably haven't demonstrated it fantastically in Northwind Traders, but I really want to focus on those big concerns. So maybe it might be just things like customers, orders, and products. Maybe that's all that Northwind Traders needs. And so it'll be those commands and queries associated with each of those 3 big things, rather than mapping explicitly to each entity. Because remember, in the application layer, what we're trying to model is any business logic, those business use cases that they provided to us. So creating an order might be working with a whole lot of different entities and working with external infrastructure as well. So it's really about what does it take to create an order, rather than these are the commands and queries for the order entity. Yeah, so I think, yeah, it depends on your design. Let me get rid of that. Get rid of that. Where were we? So we're moving on to application layer. And I just wanted to show you. Oh, it's not. Sorry. Thank you. Probably help. Okay, so this is a previous commit of the customers, and I wanted to show you this just because it's a simpler way to approach CQRS than what I'm doing now, but then I'm going to show you the new way because it comes with a lot of advantages. So you can see here I've got my customers queries, and I've got a get customer list folder, and it contains the model, the interface for that particular query, and the actual query implementation itself. So if I have a look at the get customers list query interface, it's quite simple. It doesn't have any input arguments, and it just returns a collection of customer list model. And that's all it is. So that's the type of thing that I'm going to inject into my, say, ASP.NET Core Web API controller. And then when they call get on that controller, then it's this query that I'll use, this interface that I'll use. I'll call execute, and that'll return the results. So if you look at the implementation, it's really simple as well. So you can see it's a class that implements I get customers list query. I'm using the DB context directly, so I use dependency injection to put that in there for me, and then I just grab the results. And that's all it is. So that's the query. But what you can see there is, yes, I've got a query that's to get a list of customers, but it's completely implemented within this class. And there's only one place where it's implemented. And we're not confused about anything else that we might need to do in relation to customers. And if we're looking for other things relating to customers, we know exactly where to go. This one is get customer detail. And so we can see the interface here. It's quite similar. We just pass in an ID, and it's going to return us the customer detail model. And the implementation is exactly what you would expect. It's what we need to do to get the customer details. So the commands aren't much different. They just have a single responsibility, and it's implemented within the class. So the create customer command, you can see it takes in a create customer model, everything we need to create a customer, and it just saves it to the database, and it also sends a notification out to some external service. So that's the old way of doing things, but I want to show you how I'm currently using it. And what I'm currently doing is using a tool called Mediator. And Mediator is all about messaging. It makes it simple to implement commands and queries, requests and responses, events and notifications. Load that up. Anyone heard of Mediator before tonight? Anyone heard of AutoMapper?
Yeah.
Yeah, so same guy, Jimmy Bogard created Mediator. So, okay. So let's have a look at how customers looks now. So it's evolved a little bit. Instead of having the interfaces, we don't need those anymore. We just have this create customer command and the create customer command handler. And the create customer command is really important. Let me zoom out of that. It's a DTO. Currently, it contains a create customer model, but that's not the way that I like to do it nowadays. I actually like to take the contents of that, which has all these data annotations. We'll strip them out. And put it straight into the command. So the command, you know, the command is not going to be the same as the other DTOs that you might have. So if we strip these out, contact title, there we go. So that's just all of the things that we need to create a customer. And then the handler takes in that command and just takes action on it. So we can actually just go delete that and change that over to the request. There we go. Okay, so the command is the DTO, and it's everything that we need to run the command. So the query is the same. If we have a query, the actual query object is the DTO, and then we associate that with a handler. And the reason that I'm using Mediator is because it makes it very easy. So you see this create customer command inherits from an iRequest of type customer detail model. So that tells Mediator, hey, this is a request, and the response type is going to be customer detail model. And then over here, we have the create customer handler. And so this is a Mediator iRequest handler, and it says I handle a create customer command, and that returns a customer detail model. And so it's similar to how we were doing it before, but it's a lot easier to use. So the implementation hasn't changed too much. But when we use it, I'll show you later when we use it. It's a lot simpler. Let's see. So we were talking about validators. I've got a validator on this create customer model. So there's quite a few ways that you can do validation with .NET Core. So the first one is data annotations. And data annotations are fine. They're simple and they'll work with your ASP.NET Core pipeline with the model state. But they don't really work very well for any complex validation scenarios. Like if you need to check on the state of one field and then validate another field, you can't really do that effectively. So what I like to do is to use a tool called Fluent Validation. And with Fluent Validation, I don't actually need any of these data annotations. I can define it all using the Fluent Validation API. So if we strip those out, and we can have a look at our validators. So I've got a create customer model validator. And you can see here, it's an abstract validator which comes from Fluent Validation. And it's for create customer model. So Fluent Validation wires up through dependency injection, and once that's done, it's actually integrated fully into your model state. So when you are checking your model state to see if it is valid and it's returning all of those errors, Fluent Validation works just like that in exactly the same way with exactly the same objects. So you don't have to do anything differently on that side of things. So the model state might contain an error that says customer ID is required. So you can see here that I've got all of the basic rules that we were running with data annotations. But as I said, Fluent Validation actually can do complex scenarios. So if we have a look at this update customer model validator, I'll just get these out of the way so we have maximum space. You can see I've got all of those simple rules there, like maximum length and not empty. But then I also have some more complex rules. So I'm saying I need a rule for the postcode. And this rule applies when the country is equal to Australia and the postcode must match this regular expression, which basically says it has to be 4 digits. So that's quite good. That's based on the country. And then I have another rule, and it says this rule is for the phone number, and it says when the country is equal to Australia and the postcode starts with 4, it must have a Queensland landline. And this is a function that we've created to check that the phone starts with these numbers. So this is a simple example, but it does demonstrate a little bit of more complex validation logic. And the cool thing, yeah, as I said about Fluent Validation is it just pipes right in. So when you check your model state, it's going to be running these and it's going to return the errors. So when you're using, yes, question? Let me.
I have some base model.
Mm-hmm.
Say, for example, client.
Yes.
You made the validation as using the Fluent, and
Mm-hmm.
then create from that, say, person and company,
Mm-hmm.
and put validations over there. Can I reuse or inherit somehow base model validation and plus on top inherited model validation?
You know, I haven't tried that. That's a really good idea. I don't see why not, because this derives. You'd have to try it, I think.
It's like with AutoMapper, right? It's just
Yep.
thinking of associations. You need explicitly say this would be inherited from that, and then reuse base type mapping or whatever. So is it similar concept over here?
Yeah. So the question was, if I have some base type that's inherited, say, from other types, can I have a validator for the base type, and then a validator that builds on that from the derived types? So yeah, actually, I haven't tried that, so I don't know the answer. I'm not sure if it'd be similar to the way that AutoMapper works. It's a really good question. A lot of the time we do have a base entity type, but in this case we're working with the view models and the DTO, so I don't tend to have those derived from anything, so I guess it's just not something that I've encountered. Worth a try though. So I wanted to show you also how we can do manual validation with Fluent Validation, because
Can I ask a quickly?
yes,
What class did you put the validation on? Where does it sit in your architecture?
yes. So it's right here in the application layer, and I'll just zoom in for you. So in the customers folder, I've got my commands, models, queries, and validators, and so it sits in the application layer, and it's just here. So if I look at the update customer model validator, it's a validator for the update customer model, which sits in the models folder just above it. So there's the model, and there's its validator.
Right. So the update customer model
Mm-hmm.
is a clean class with nothing on it,
That's right.
and then okay, and the validator takes that as an argument.
It actually takes it as its class definition. So it's based on abstract validator of update customer model. Yeah, and then you just define your rules around it. So you can get access to the underlying model you see in this case. So one of the things that you might need to do, depending on the design of your application, is actually manual validation, because maybe you're not building any kind of ASP.NET Core application, or maybe you've got multiple applications that are talking to this application logic. And that's what this architecture is about. So it's quite easy to do manual validation with Fluent validation. I've got an example for you in the update product command handler. Oh no, it's not in the update product command handler. Let me check. Must have been one of these. There it is. Okay, so you saw that we had an update customer model validator. So I can just go ahead and new that up, and then I can validate the model. And it basically says validator.validate the model, and then it has the result is valid, and I can also get access to the underlying errors, of course. In this case, I'm just throwing an application exception. I'm saying that there's an invalid model exception, and the type of model is the name of the model, which would be update customer model. Now that's not a great exception, because really I want to pass the errors through as well, but it's an example of exception nonetheless. And down here, I've also got an entity not found exception, and in that case I pass in the type and the ID of the entity that wasn't able to be found. So one of the things with Mediator that I unfortunately haven't had a chance to try yet is that you could actually create, as part of the Mediator pipeline, an injection point for the validation. So I might show you some logging and error handling that I've written and show you how you might actually do your validation as part of that. So I said that Mediator came with some advantages, and one of the advantages I found is that it's quite easy to work with its pipeline. So I created a request logger. Now a request is any command or query that's run in the application, and in this case they're all commands or queries. Anything that comes through the application is a command or a query. So if I'm logging a request, I'm logging everything that happens in the application. So you can see this is of type iRequest preprocessor, and that means it happens before the request is made. And what it does is it just injects a .NET Core logger of type tRequest, and when it's time to process, it takes the name of the request. So the name of the request might be create customer command or get customer details, and then it logs some information. So you can see it's just logging out the name of the request and the actual request itself. So if you're looking in your logging tool, you're going to see Northwind request, get customer detail, and the request would contain the ID of the customer as a JSON object. So that's really useful. And you can see I've got a point there to add the user details. Now we've done this in a production system, and that means that if the user calls us and they're having an issue, we can say, okay, what's your username and approximately what time did you have the issue? And we can see every single request that they've made and the arguments that went into that request. And of course, with the logger, we can also see the exceptions there that are associated with it. And we've done that for the entire scope of the application logic, basically with just this one file. So this was one of the reasons that I actually started to love Mediator. These sort of things become simple. Now, if you have a look at this, I have a good opportunity here to actually do some fluent validation. I can actually say, hey, is there a validator for this request? And is it valid? And then return some sort of other result to actually say, no, this request failed because you didn't meet the basic requirements to make this request. So we could actually implement any kind of validator across the entire application level, as long as we're using Mediator for our commands and our queries and those other sort of things. So that's something that I'm definitely going to be trying next, because we need to remember that it's not necessarily going to be the ASP.NET Core Web API that's going to be performing the validation. It could just be a console app, and we still need to perform the validation. Like, we can't run the command unless we've got valid data to work with, so we need that check. So the other thing that I did was I created a little performance behavior, and that's a logger as well, but it wraps the request. So you can see I'm injecting a logger, and then I've got a stopwatch, which is from system.diagnostics. I start the stopwatch when it's time to handle the request, and then we wait for the request to finish, we stop the stopwatch, and if the elapsed milliseconds is greater than 500, greater than half a second, then I log a warning to my login provider. So it could be Seek or Application Insights or something like that. We're using Seek a lot. And it basically will tell us if there's any long-running requests. And we might not get a chance to action them straight away, but maybe if we do get some time in the next sprint for optimization, or maybe if the user complains because a particular area of the application is slow, we'll have some information kind of to help us. Maybe it's slow at a particular time of the day. That'll be there ready for us to diagnose. So that's pretty cool. Let's see. So we've talked about exceptions. Probably the other thing that I want to talk about is view models. And I've created some different view models for the product section. So we have a DTO, and a DTO is a data transfer object. And I'll just zoom out again. So you can see it's quite simple. It just has basic getters and setters. And maybe we're mapping it from an entity or some other source. It doesn't really matter. It could be coming from an external source, but its purpose is just to transfer data. It's not really suited for use with a view, although you could use it with a view. But then I also have some product view models, and this is really important because I feel like view models are being underutilized in the solutions that I'm seeing in nowadays. So you can see the product view model, which is obviously going to be associated with a product view, maybe view details. It contains the product DTO so that we can display the product details, but it also has two properties. It has edit enabled and delete enabled. So what we're actually doing is when we get the product detail, we're also querying permissions at that time and checking to see if the user is authorized to edit or delete this product. Now, the alternative that I see sometimes when people are building single-page applications, they get the product DTO in one request, and then they make another request to get the permissions, and then they have logic on the client side to actually determine whether these edit buttons or delete buttons should be enabled. But that's on the client side, and we can't use that anywhere else. So by putting it in the view model, and thereby enabling us to provide that information in the application layer, we can use that anywhere. Even if we're building a console text-based UI, we still know if that user is able to, edit those products or delete those products, and we don't have to ask any questions about that at that side. So I think view models are definitely underutilized, and if we empower them with those sort of properties so that we don't have to ask questions on the client side, we're going to be a lot better off. Even simple things like ordering can be covered off. So if you see in this view model, we've got a list of a list of products. If there's a default order, don't wait till you get to the client side to order that. I've seen that before too. Actually do it in the application layer and then return it. So my point there is utilize view models. They're very powerful, and know the difference between a view model and a DTO. All right. So I think we're a little bit through there. So the key points, you can use CQRS to simplify your overall design. Don't be scared off by people talking about separate data sources and event sourcing and all that sort of thing. It really is just a great tool for separation of concerns. You can use Mediator to simplify your management of requests and responses, commands, queries, notifications, and events. So this is a simple design, but in a complex design, you might have domain events or some kind of application events. Mediator supports that too. It'll just create handlers, and it'll respond to those events when you raise them. In the past, you'd have to write kind of your own code to have those events working. But with Mediator, all of those things become very trivial. Know the difference between view models and data transfer objects, and when it's right to use one, make sure your view models are rich. Use Fluent validation for complex validation scenarios, and finally create custom application exceptions, because they're going to be a lot easier to diagnose than those out-of-the-box ones. All right, so now we're going to have a talk about the persistence layer. So in this case, the persistence layer is something that we're depending on from the application layer. We've chosen to take a dependency on EF Core, and we're okay with that. If we had decided to go the other way, then we would have implemented some abstraction, and that could have been the repository or some data service that we've created. So our persistence layer is going to contain our DB context, any Fluent API configurations, our migrations if we're using EF Core migrations, any seeding logic, and abstractions. So that would be the implementation for the repository, implementation for the data service, that sort of thing. So let's jump in. So I keep persistence inside infrastructure just to make it clear. Let's have a look. One of the things that I talked about was preferring Fluent API configuration over data annotations. So there's a couple of ways you can do that. You can actually, in the DB context, you can specify on model creating how an entity should be configured. And that's fine for really simple DB contexts that maybe contain just a couple of entities, but not for anything of size. This will become too big, and it'll contain configuration for all types of entities. So what I like to do is just create a little configurations folder, and inside of that I put in entity type configurations. So if you have a look at this customer configuration, it's of type entity type configuration, which comes from EF Core. It's of type customer, that's the entity type. And all we have to do is have this configure method, which actually defines how the customer should be built. So you can see it has a key of type customer ID, which is not really a good practice, because if we look at the customer, the entity name is customer, and the key is customer ID. So we know by convention that Entity Framework already knows that's a key. So I'd definitely say use conventions over configurations whenever possible, and know your conventions. Entity Framework knows that's a key, so we don't need to tell it again. That just makes this class a little bit bigger and a little bit harder to understand. And that point is true of any conventions-based framework. So if you're using AutoMapper, for example, you're going to be much better at using AutoMapper if you know its conventions well, and then you're going to know where it's strong and where it's weak. So you can see there that I've basically defined everything using the Fluent API configuration, and because of that, my customer entity just has its properties. It's quite simple. Any questions? No problem. So I wanted to talk to you about the value object that we saw early on. It's quite simple to configure those. I've got a user configuration here, and all I have to do is say that this entity type builder of type user owns one AD account. And what that results in is Entity Framework maps it to the database based on its public properties. So in this case, the AD account has two public properties. It has the domain and the name. And so in the database, what it will do is it will create in the user table, it'll have AD account underscore domain as one column, and AD account underscore name as the other column. And so all you have to do is specify that it owns one AD account, and Entity Framework Core takes care of the rest. So it's quite simple to implement those value objects. Let's see.
So basically, when we make a request and we get the object back, that will inflate into the You're going to have your user, and then you're going to have an account property with those two.
Exactly. Yeah, so then with the example that we saw before, I'll just save that, it becomes trivial to work with user. So we've got really great implicit and explicit conversion operations for the AD account, so we can create an AD account type really quickly, and we can get it back from the database really quickly. We don't have to worry about it. Okay, so one of the problems at the moment with Entity Framework Core is, yeah, we have all of these configurations, but the normal way of wiring them up is actually, ignore that, is actually to say model builder dot apply configuration, and then we have to say new category configuration, and we have to do that for each one because there's nothing out of the box to do anything different. And so you can see I've got, I don't know, 11 configurations there, maybe 12, and I have to do that for each one, and I'm going to forget to do it. So I've created a little helper class, and that is apply all configurations. So it simply just uses reflection, scans this assembly for any I entity type configuration classes, which is that base type there, and applies them. And that's just through this little extension method. So you can see it's simple, but it means that I don't need to remember to do that anymore. And I also don't have to look at that because I don't really like looking at that. I've got to refactor this a little bit. Shouldn't be calling things its and I's. I need to be a little bit more descriptive. But it's just using reflection, and it's just applying the configuration as if we'd done it ourselves.
Sorry, doesn't the framework automatically pick up all these entity configuration?
No, you have to apply them. In Entity Framework 6, it had a method similar to this, so that it would apply it, but no, it doesn't pick them up automatically. Entity Framework Core doesn't do it, no. Yeah. Have you had a different experience?
I think it did.
Yeah. No, that's, yeah. So, sorry, I should have repeated the question. So the question was, doesn't Entity Framework Core automatically pick up these configurations? And as far as I'm aware, no, it doesn't, but it sounds like you might have had a different experience.
I'm not quite sure because these configurations of that type, the generic interface,
Yep.
I had to stop using them because we had a base entity for AF context.
Yes.
And then we inherited two different AF contexts because we had databases which is slightly different.
Oh, yes.
And we need to write some, initialize this or that.
Yes.
depending
On the database.
yeah.
Yeah. Okay. No, that's fair enough. Yeah. So no, I don't think it does it automatically, but I would love it if it did, because then I could get rid of that, which would be cool. So the other point that I made is that although we've taken a dependency on Entity Framework Core, we're still independent of the database. So if we want to actually change out the database, we can do that. So currently, if we have a look at the configuration of the persistence, just by editing to northwind.persistence.csproj, you can see that the provider that's being used is SQL Server. So if we wanted to change the database to something else, we just need to change this provider. And we've actually done that with this project. We've changed it from SQL Server to Postgres, and it was quite simple to do. Be a different story, I think, if we wanted to change it to Cosmos DB. But certainly, because Cosmos DB is NoSQL and SQL Server is relational. But Entity Framework Core supports both. So it'd be an interesting exercise to try. Okay, so the key points there is that it's independent of the database. We can switch that out for a different provider. It's good to prefer conventions over configuration. It's important to know the conventions because otherwise you're not going to be able to use them. Use Fluent API configuration over data annotations so that you don't have to have those attributes messing up your entities. And use the extension to automatically apply all of your entity type configurations. So you can grab that from the source code and use it. So now let's talk about the infrastructure layer. We're not going to spend too much time on this one. The important thing to remember about infrastructure is it's everything else external, and no layers depend on infrastructure. If a layer depends on infrastructure, then that means that you're going to be writing logic to interact with that, which is outside of the application layer, and you don't want that. So what sort of things are external? Well, any kind of external client, so accessing a WCF service, any kind of RESTful API service, anything at all. File systems, that would go in infrastructure. If you've got logic to access the file system, you put the implementation there. Any kind of notification. The system clock is a good one. You know, you might not think about abstracting the system clock, but if you've got code that's using datetime.now, well, that just became, and especially if there's logic associated with that datetime.now, that became harder to unit test. Because if it's something that happens on a Wednesday and you only run your tests on a Tuesday or, well, every other day of the week, that test is probably going to fail, right? So if you abstract the system clock, then you can provide a mock for your unit tests. And you can also do something else which is interesting, which is put an administration configuration in your UAT environment so that you can set the date and time for the UAT environment, or allow the users to set the date and time, because then they can test things that are time critical from the UI perspective, which is great. We've done that. So it's anything external. So in the infrastructure layer, I've just got a pretend implementation for the time being, but we can have a look at the implementation. So this is a notification service, and all it does is implement the iNotification service interface, and that interface, of course, exists in the application layer. So that's why infrastructure has that dependency on application, because that's where its interfaces are. Now, if we want to change this implementation out for a more advanced implementation, maybe one that doesn't throw an exception, we can do that, and we're not going to affect any logic inside the core. We won't affect the application logic or the domain logic, as long as we adhere to that interface. So this type here, this message type, that's also coming from the application layer. We don't want to be passing types back from external services because we don't own those types. It makes it harder for us to work with our application. So we only use our own DTOs. So we've got a message DTO here, and it contains all of the things that we want to actually pass to that notification service. And that's, of course, defined in the interface, which specifies we're going to send a message. So it's really simple, but that's really the design. That makes sure that everything outside of the core stays outside of the core. And you can see, yeah, there's the interface, and it's just inside the application layer. And I think that's it. You know, don't really need to spend too much time on infrastructure. Key points: contains classes for accessing external resources, so the implementations, and it implements interfaces within the application layer. It utilizes DTOs or any kind of model, and those DTOs or models are defined within the application layer. And no layers depend on infrastructure. So I have seen where people will have this really nice design, and it's designed in this way, but then they've got the presentation layer with a dependency on the application layer, and then also a dependency on infrastructure. And that just causes them to write logic to bring those two things together. So you'll typically end up with like a controller that has logic in it that's bringing in external resources, and of course it's in the presentation layer, so you can't use that in other apps then. So that's why we don't do that. So next and final section is the presentation layer. This is an ASP.NET Core talk, so we're talking about applications like web forms, MVC, Razor Pages, Web API, or single page apps. Of course, you can put anything you want in the presentation layer. So it could be a console app or a Windows service, a WCF service. It doesn't matter because we've really nicely encapsulated all of our logic in the application layer and the domain layer. And so we're free to use anything, and we're free to switch those things out. It's going to be pretty simple to do that because our logic is elsewhere. We could also put Blazor in there if we're really brave. You know, it probably wouldn't be so bad with this architecture and design. It'd be kind of a minimal investment. That'll be the next thing I try. So I'll just take a moment to, if you guys could pass out these evaluation forms and complete the evaluation. Really appreciate it.
Thank you.
Let's talk about the presentation layer. So the presentation layer is interesting. At the moment in the Northwind project, what I have is a web API, and what I'll be adding to it soon is Spa, probably based on Angular, and Razor pages, because I really want to demonstrate how this architecture and strong view models can make a big difference in how easy it is to build these front ends. But let's have a look at the web API, and I want to talk about two things. I want to talk about building really great controllers, and I also want to talk about Open API. So we'll start with the controllers. And to do that, we'll view a little bit of a progression in how this products controller has evolved. Okay, so you can see in this products controller, we're doing a few things wrong. We're injecting the DB context for a start, and we're returning entities directly to our front end. And that's problematic for two reasons. The first reason is that, well, an entity is not really suited to a view. We're going to need a lot more than an entity in most cases. For example, if we're actually using getProduct as the basis for rendering a form to create a product, we'll probably need to get a list of categories as well, and we'll probably need to get a list of suppliers and that sort of thing. So we'll be making multiple requests. So as we know, a view model will be much better suited for that. But the other thing is that because we've gone so low level with the DB context in the controller, we don't have anywhere nice to encapsulate our business logic. We're forced to pretty much write it here. So those commands and queries that we have in the application layer, well, you can't use them. You have to actually put the logic in here. So that's pretty typical, though. You see a lot of controllers like that when you're working with systems. But let's have a look at the next progression of that controller. So in this one, I've actually used the original design that I had for commands and queries. I just have the interfaces, and I go ahead and inject them in. So you can see I'm injecting all the queries and the commands that I'd need for working with products. And then I go ahead and use them. The design's much better. My logic is encapsulated in the application layer now. And the controller is really skinny. I don't have to have much in there at all. And really, when you're writing controllers, you do want them to be as skinny as possible. They shouldn't contain any logic. So that's good. But let's have a look at the next, my history. So you can see before I was injecting them into the constructor, and that's okay, but the way controllers work is we're not going to need all of those commands and queries for a single request. So what you can actually do is use this from services attribute. And that's part of the dependency injection. So it's not coming back from the client, it's dependency injection. And that will actually say, hey, go to the container and inject the get all products query for me. And so that makes things a lot simpler. So now I can just say query.execute, or I can say return OK, await query.execute. So that was kind of a nice evolution, a little bit better. And then I started using Mediator. And so you can see with Mediator, we only have one dependency, and that's one of the great things about Mediator. You just inject Mediator or iMediator. And then we can access our queries and commands just by sending Mediator requests. So we go mediator.send and our query, so get all products query. And it'll return the result from that. So the result will be IEnumerable product DTO. So we do that with anything. So now we only have one dependency. We don't actually have to worry about what we need to inject, because Mediator's wired it all up for us.
I have a question about this.
Yes.
How would you automate transactions when you need to update zero latencies at once?
Well, that happens on the application layer. So we're using a DB context that has an implicit transaction. And yeah, so it would be encapsulated within that command or query or method that you create within the application layer. So as far as the controller is concerned and Mediator, it just has one job.
Oh, no, yeah, okay.
Yeah. You think of it, I like to think of it as glue. It's the glue for a controller that converts a request into a response. That's all it does. And now our controllers become completely infrastructure. There's no logic in there, and there's nowhere really to put any logic anymore. So it certainly sets a good example for our other developers. But I got sick of injecting mediator. I didn't want to inject any dependencies. So I created this base controller. And now I just expose mediator through there. So this is a property called mediator. And I just use property injection to actually get that iMediator service. So now any controller I create that I want to use mediator, I just inherit from base controller, and it's just there ready to use. So that's pretty cool. Very simple. Maybe I should call it mediator controller. Originally I had logging in there as well, so that I could use logging in my controller, but I thought, well, I don't really need logging in my controller anymore because it doesn't do anything. It's either going to work or it's going to throw an exception, right? So all of my logins in my application layer, and it's across all of my requests. And if it throws an exception, well, that's going into the log anyway, because my login's good enough for that. One thing that I didn't show you guys was the custom exceptions. And I think it's in the products controller. So if we throw an exception from the application layer, maybe we want to intercept that at the web API layer and handle it in some way. And of course we could have a try catch block on our mediator request, but that would be painful. So there's actually a little simple filter that we've got here, which is called custom exception filter. And basically it can be applied to a class or a method. And anytime an exception occurs, it will evaluate that exception. And if it's one of our custom exceptions, such as entity not found, it's going to turn the response into a not found result. So web API will return a 404. And we don't have to do anything, like we don't have to have a try catch block or anything like that. So you can definitely build on that. That's just one exception. But by using that filter, we're good to go. And actually, you don't even have to put it on the class. I think that I've wired it up. Yeah, I've wired it up in startup. So it just applies globally, which is pretty cool.
Usually in this case, it's good to have a validation exception. And remember, when you
Yes.
do validation, it returns you a list of validation results.
Yes.
And you can just, if it's validation exception, just return the whole list because
Yeah.
they're more likely to have good naming.
Exactly. Yeah. So the statement was that it's good to have a validation exception in here to catch that validation exception and to return the whole list of model state errors, I guess. And it's good to have all of that information there. And yeah, that would be a great progression for this one. So we could return that as a bad request or some other suitable type if we prefer, and include the full model state. So we'd intercept those errors as well. One of the cool things in ASP.NET Core 2.1 is they've actually, if you're building web APIs, they've introduced this API controller attribute. And if you apply that, it actually does model state validation implicitly. You don't have to actually say, if not model state dot is valid, do return a bad request. It just does that, which is cool. And the other thing was that we'll talk about that soon, actually, I think. Yeah, let's do the last thing. So I wanted to talk about OpenAPI. Show of hands, who's heard of OpenAPI? Okay, one person. Who's heard of Swagger?
That is for OpenAPI.
Yeah, trick question, right? But more people have heard of Swagger. So most of the room's heard of Swagger. So Swagger is now known as OpenAPI. And I like to think of OpenAPI as bridging the gap between the back end and the front end, because I'm building a lot of spas, and so when I talk about bridging the gap between the front end and the back end, I'm talking about all of those view models and DTOs I created, regenerating them on the front end and not having to write them myself. And I've got a web API, so generating a client so that I can access that web API without writing that code myself. It's quite trivial to implement, so let me just show you that. I've got a couple of tools here. Oh, got a few things to fix. Yeah, that happens in this demonstration. So I have a seed method that's just not ready for a private setter yet. That should about do it. Just do a quick build. Okay, so when people talk about OpenAPI Swagger, they're saying that it makes it easy for humans to understand these RESTful APIs, and it also makes it easy for computers to understand RESTful APIs. So it makes it easy for humans to understand the APIs because we have tools like Swagger UI, which read these OpenAPI specifications and can tell us all about the web API that we're using. So this is Swagger UI. And you can see here it's got a list of what are essentially controllers in our application, and also all of the methods or actions that we're able to perform on that controller. And we can actually jump in and try it out. So if we wanted to go and get a list of products, we can execute that and see the results. So we can learn, as developers, we can learn a lot about the API and how we might interact with it. But also it describes the models that are part of this API, all of the different types that you might expect and what their shape is. So we can see that product view model that I created, you know, it contains a product, which is a product DTO, and it has some flags for edit enabled or delete enabled. So as humans, that's great. We can understand that. But then we can also use tools like NSwag Studio, and NSwag is a tool for working with OpenAPI, which can read the specification and generate code for us. I should show you the specification quickly. So this is Swagger UI, which is reading the specification, and our specification is here, and it's in JSON format, and it's just, yeah, not great for humans, good for computers. So if I take that URL and paste it into NSwag Studio, I could do things like creating a TypeScript client, and a TypeScript client would definitely be useful for a single page application using Angular. So I'll change my TypeScript version, change the template to Angular. I'll say that we're working with Angular 6, and we'll use the HTTP client. So we're configuring a whole bunch of options, but we don't need to go through that. The idea is that you can configure a lot of different aspects about the code that's generated, and if we go ahead and generate outputs, it's going to, that's unfortunate. I wonder why. I might have to read it. Index out of range. I wonder why. Let's revert and just try once more, because it's really cool to see that generated. I don't want to do that. Undo. Try and launch it again. Any questions about OpenAPI while we wait? No worries. Well, it launches. No, it's not going to happen. That's disappointing. So what we can generate is a TypeScript client, so we can use that with Angular. And what it would generate is services for interacting with our web API, so actual Angular services. So we could use it, it would create a customers client, and we could inject our customers client into our Angular component and actually get customers, create, update, delete customers, but it also generates all of those view models as well. So the view models and DTOs, they're available on our client side and ready to use. So that's the kind of thing that we would have had to have written from scratch in the past. But the source of truth was always the back end. So now we can use OpenAPI and a tool like NSwag Studio to generate that for us so that we don't have to do it. And when you've configured it, it becomes as simple as typing nswag run or just integrating it into your build pipeline, and that code is automatically generated for you. So very simple, but really powerful. All right, so key points. Controllers should not contain any application logic. That belongs, of course, in the application layer. All application logic belongs in the application layer. Utilizing OpenAPI bridges the gap between the front end and the back end. and you should create and consume well-defined view models. So I have some recommended resources for you. The first one is my Northwind Traders sample solution. So you can grab that from bit.ly Northwind Traders. And I had to dig up that logo. It was pretty hard to find. They used it in Access, so, but it's the authentic logo, so I didn't want to choose anything else. So this includes all of the code that we've demonstrated tonight. And if you wanted to go back and look at the history, you can. There's quite a big commit history there. So then there's this book, which is about building monolithic applications. And so this is the book that first introduced me to clean architecture. They've updated it to ASP.NET Core 2. I believe the 2.1 version is on its way, but the author has already updated the associated sample application to 2.1. So that's worth checking out. Then I'd also recommend reading this book. And don't be put off by the fact that it's talking about containers and microservices. It talks about a lot of other great things, especially the DDD concepts. That base value object that I demonstrated for you earlier, that came from this book. And so these books are both free. So you can get the PDF or the Mobi or just the web versions. And they contain sample applications. So there's a sample application in the first one of clean architecture implementation, and in this one is a sample of that broken up into microservices. It's quite a natural progression. And then, of course, there's the book Clean Architecture by Robert Martin. So this was released last year in September, I think, and it goes into the full amount of details. So everything that I didn't cover here today is in this book. I'd recommend them probably in that order, especially if you're new to this type of architecture and design. I think that that first book does very well in guiding us through it and making us, helping us to understand why it can be so powerful and how we can use it. So finally, any last questions? Yes?
Logging.
Yes?
So I've seen, in one of the examples that was injected into a class that was logging.
Mm-hmm.
Now, if a class has like 2 or 3 other dependencies, that because it depends on objects,
Yes.
by introducing a logger class, that puts an additional dependency on the class.
Yes.
And depending on the size of the application, this can exist in many, many places.
Mm-hmm.
Is there a better, cleaner way of using a logger in the class without actually having to inject it?
Yes.
There used to be something called the ambient context pattern, and it used to gather a little bad rap. Because you would make your class depend on the static.
Yep.
I just don't see a way to cleanly you consume a logger.
Okay.
In a consumer class.
Yeah. So let me repeat. So logging is the question. And we might have classes that have a few dependencies, and actually adding another dependency to that might be a bit too much of an overhead. But I think the good thing about .NET Core is that the logger is just an abstraction. So it's very lightweight and it's available anywhere. So injecting the iLogger isn't going to create a load on your application. It's really the providers that you associate it with. So if I was going to optimize anything, I'd be looking at the provider that I'm using and making sure that that's efficient.
Yeah, I mean, I was mostly referring to it in terms of readability. You could have like 4 dependencies in a class, which means that it does a lot of things.
Yeah. Well, certainly there's things you can do, and there'd be nothing wrong with moving the iLogger into some kind of abstract implementation that you put in a common library, or having some sort of base class for things that use logging. Like that was something that I was considering doing for the controller. I actually had a logger in my base controller class, and that was just available, so it didn't need to be injected. So you could consider that. Yeah, but I think the key point is that it's quite lightweight, and you can configure and interchange your providers as needed. Any other questions? Yes.
Does mediator exist for non-core applications?
That's a really great question. I believe it does. It's been around for quite a while. I've seen some of the references back to 2015 and earlier. So, yeah. So the question was, does mediator exist for non-core applications, .NET Framework, that sort of thing, and I believe so. Just jump on to GitHub and check it out. It's open source as well. So, any other questions? No worries. Thank you very much.